Right, so another calculation related question. So carbon reacts with oxygen to produce zero point 0.4 mole of CO2 and with the release of 40 kilojoule of heat. Which of the following statement is true for the above system? So we have carbon solid reacting with oxygen gas and it forms CO2 gas and zero point 0.4 moles of CO2 is formed and the delta H is given as 40 kilojoule. Okay. So when you see this question, so there is carbon 1 is to 1 is to 1. So there is 40 kilojoule that is given out. So if you want to obtain like let's say 40 kilojoule uh, heat to the outside, so normally you heat like 4 moles of carbon solid with 0 0.4 moles of 0 0.4 moles of O2. This is also moles, and you will have 0 0.4 moles of CO2, right? So we will discuss what is actually happening here. 100 kilojoules of heat is required to decompose 1 mole of CO2 into carbon solid and oxygen gas. So they are now telling the other way around, right? So it's like 40 kilojoule. Okay, it's like 40 kilojoule is necessary for 0 0.4 moles of carbon dioxide. If this is formed, the other way around is decomposition. What is the energy for 1 mole, right? So when you do the cross multiplication, you will see 40 is equal to 0 0.4 times x. So x is going to be 100 kilojoule. 400 over 4 means 100 kilojoule. This is like mango questions. When 2 mango is equal to 10 rupees, what is the price of 10 mangoes? You do the cross multiplication. So in the same way, when carbon and oxygen combine, 40 kilojoule is formed. So that is released. So what is the reverse? When carbon dioxide get decomposed, 40 kilojoule is going to absorb. So they say when 1 mole of carbon dioxide is going to decompose, so we should give energy to decompose, right? Because here carbon dioxide is when forming, it releases. So when you want to decompose the reaction towards the other side, we have to give energy, right? So for 0.4 moles, 40. So 0.8 moles, 80. So for zero point 0.2 moles, another 20. So 100 kilojoules. You see this? That is what they have given. 25 kilojoule of heat is required to form 11 gram of CO2. Okay. So how many grams that you can calculate? 0 0.4 moles. Then 0 0.4 mole is formed when you try to multiply this by the molecular weight 44. You will realize the grams that is formed. Okay. So you get the grams. Then you can deduce that 40 kilojoule gives this amount of grams, then 25 kilojoules should give this amount of grams. Okay, so you can imagine. So when you go with grams, that is not always good. Okay, so try to go with moles and then try to convert that into grams. For an example, 40 kilojoule gives 0 0.4 moles. Then try to calculate for 25 kilojoule how many moles. So we will do that. So 40 kilojoule gives 0 0.4. So 25, let's say y for an example. So you see here 25 into 0 0.4 over 40. So this is 4 over 400 is 1 over 4 over 400 is 1 over 100, which is 0.01, and it will be 0.25, right? So 0.25 multiplied by 44, you can get the value here. This is 1 over 4 times 44. So it will give 11 grams. So basically, if you want to decompose 11 grams of CO2 in the other way around, you should give 25 kilojoule for an example. Okay. C, sum of enthalpies of the product, which is CO2, let's say, is less than the sum of the enthalpy of the reactants. Sum of the enthalpies of the product is greater than the sum of the enthalpies of the reactant. So what do you say about these two? There is an enthalpy for these two, and there is an enthalpy for these two. You know, we already know these two are correct, but we have to elaborate these two. The reaction enthalpy is 40 kilojoule. That is the release, right? Carbon solid exists as a solid in the natural state. Oxygen O2 gas also exists as in the natural state as O2. So the formation enthalpy of carbon and oxygen is automatically going to be 0 anyway. But CO2, they have to form from carbon and oxygen, right? And here, when this reaction happens, it releases 40 kilojoule, which you should understand this reaction is exothermic because it gives out heat energy, right? So when you do the enthalpy calculation, delta H is the delta H of the product minus delta H of the formation of the reactants. So this is formation is 0. So this product enthalpy should be a negative value, negative 40 in fact. That is when this delta H becomes negative, as they have given in the question. It releases 40 kilojoule. So automatically you see the product enthalpy is a negative value, right? And this is 0. In fact, 0 means the enthalpy of the reactants. The final enthalpy is negative 40. So the reactant enthalpy is 0. The product enthalpy is minus 40. That is when you get the overall as minus 40, which is the release of 40 kilojoule. Okay. So according to this two, you can tell which is more less. This is less. The sum of the enthalpy of the product is less than the sum of the enthalpy of the reactants, because this is 0, this is negative. This is correct. The sum of the enthalpies of the product is greater than the sum of the enthalpies of the reactants. Okay, this is wrong. So A, B, C is correct. So that is why the answer is 5. So A, B, C is correct. But don't forget, this reaction depends upon many other factors also, right? Because they say carbon solid react with oxygen to form 0.4 moles of CO2 gas, right? Where is the temperature here? No temperature is given. And we don't know whether oxygen is excess or not, how much carbon solid is used or not. So there are many points that you need to consider when answering this type of question. Anyway, it is obvious these are correct, so the answer is 5 anyway. Okay, but You should be very careful with these questions.